Good evening, everyone. Thank you for joining us for tonight's presentation of a case study on installing BendixKing's new AeroVue Touch primary flight display on a Cessna 182. My name is Jeff Simon. I'm president of SocialFlight. For those of you joining us for the first time, SocialFlight is the free web and mobile app dedicated to supporting general aviation. You can visit socialflight.com or download the SocialFlight mobile app for Apple or Android devices, and it gives you access to over 10,000 aviation events, destinations, restaurants. You even get a weekly email with a list of all the aviation events happening in your local area. Our mission is to give pilots like you more reasons to get out there and fly, and it is all free. Now, in addition to events you can fly to, we also have online events, which is why we're all here this evening. Together with Stephen Pearce from BendixKing, we're going to discuss the installation process for this new system, including some of the things to think about along the way to aid your own process and help you make decisions. Before we get started, just a few tips. First of all, a recording of today's presentation will be available on socialflight.com and the SocialFlight YouTube channel within 24 hours. You should get a follow-up email about that. That'll help you link to that if you have any questions or want to see it again or have to drop off early. Now, feel free to post questions during the presentation using the Q&A feature. And what we're going to do is, as opposed to handling it at the end, we're going to try to incorporate the questions that we see come up during the presentation as much as possible. And then also you will have contact information directly for Stephen over at BendixKing at the end. And since most people have more specific questions to their aircraft or their unique situation, in many cases, that's the best way of addressing your questions and helping you make the best decision possible. So with that, let's get started. For tonight's presentation, we're going to start with an overview of everything, and then we're going to talk about the panel planning process, installation tips, and lessons learned from this installation. And Stephen, I will hand it over to you and introduce my good friend Stephen Pearce right now from BendixKing.
Thank you so much, Jeff. Yeah, so just a brief little bit about myself here. UND graduate, major in aviation technology management. I do hold a commercial multi-engine instrument rating as well. Currently working on my CFI. Been with BendixKing since 2016. Actually, October 3rd is my 3-year anniversary with the company. And many of you interact with me on a basis through the forums. So I am BendixKing's voice of Beach Talk, Pilots of America, Mooney, Space, Piper, and pretty much anything else. So if you have any questions, you can definitely reach me there, or if I need to get on a forum to answer some questions. My contact information is on the back side of this presentation. Please give me a shout out and I'll get on there and make sure that we make that happen.
Great. Thank you so much, Stephen. And just a little bit about myself. In addition to SocialFlight, I am an AMP, an IA mechanic. I've been in the avionics industry for a couple decades, pilot and aircraft owner, and also you may or may not have read some of my columns for AOPA Online and some of the other magazines out there. I also have a fair amount of experience with the FAA STC supplemental type certificate and the parts manufacturing process because I've been involved in doing that both with other companies as well as personally. So all of that and a little fun thing at the end that my boys and I are in the process of building a T-51D Mustang in our actual living room. So lots of fun in aviation, a couple tidbits about me and why the two of us will be able to speak to you about this system tonight. Let me hand this back again to Stephen. Let's talk about the features of this really, really cool system because I'm excited about it.
Yeah, absolutely, Jeff. And yeah, feature-wise, we're going to start and kind of just hit it off hard with talking about our synthetic vision that the AeroVue Touch uses. That synthetic vision actually comes from Honeywell, so it is SmartView synthetic vision. That is the same synthetic vision that is present in Gulfstream, Dassault. If you've seen the new Symmetry cockpits from Gulfstream, they run that same primary software. This obviously is scaled down so we can fit it in our box, but in terms of an industry-leading software, this synthetic vision really has it all. Coupled to the synthetic vision to make it look even better is a just short of 4K resolution touch screen, which is really sweet. If anybody's come by the trade shows that we've been at displaying this, you'll notice that everything is really clear. You cannot really see any pixelation on the screen. It is a split screen PFD MFD. The picture that we have here is showing a full screen PFD version. We do have an MFD, which is going to include all your moving maps, VFR, IFR charts that will depict ADS-B traffic and weather. The other thing that it does have, which is fairly unique to something like this, is a vertical situation display. So that's a vertical slice of the atmosphere that's going to effectively show you where you are in regards to terrain or anything like that to make sure you have the appropriate clearances. So in this picture, we just see the screen itself, but what we do not show, and this is a very nice customizable function, is the fact that there is a 4-knob remotely mounted controller here. And what that knob is going to do is that is going to control any of your primary flight functions, so baro, course, heading, and altitude. And so you can control virtually anything that is flight critical data through an external knob panel if stuff gets really bumpy up in the air. The unit does have built-in Wi-Fi. It does have the USB-C port, which is pictured on the left side of the unit there. The Wi-Fi is great. We can download databases, any sort of your updates for your unit. Updates under 10 minutes, databases under 4. Does come with a 2-year system warranty, so that's going to include all the sensors, the ADHARS, magnetometer, OAT, as well. So great system, and in terms of that, it's really a very clean setup, and it looks great in place of a 6-pack.
Yeah, and I'd like to chime in on that one also because, you know, I started my career in the avionics industry way back at the very beginning of the synthetic vision technology, like revolution, and it really was a revolution. And it has been amazing to see where that technology has gone. And a lot of the studies that we did early on and were involved in had really demonstrated that the quality of the synthetic vision put in front of a pilot, the quality of the image that is reconstructing the outside world when the windows are white, when you can't see out, has a direct impact on your situational awareness and spatial disorientation. And so the more realistic that looks, the easier it is for your brain to synthesize that and trust it compared to, you know, a scan of analog instruments or something like some of the other synthetic vision products out there that they're okay, but they don't look as realistic. And this is really phenomenal. You can see from that picture, it's a very different photorealistic style view of the outside world than what many people are used to seeing synthetic vision being depicted as. And I think that that's in itself is a pretty impressive and pretty important thing when you choose a system to be your primary display.
Absolutely, Jeff. And just these, since we are going to talk about the basis of installation for these units, it's important to just have some of the kind of dimensions in your mind of what this is going to look like. So we're seeing the total dimensions. It is a front mounting unit. Weight, very, very light, very typical current draw across here. We are working with virtually any sort of voltage, and our circuit breakers are standard for the 28 and 14 volt aircraft there. The thing that I do want to draw some attention to here is the fact that this requires no active cooling. And when I say active, there are no fans in the back of this unit pushing air around. It is a solid machined aluminum case essentially that holds us with a bunch of cooling fins in the back. And so all that this needs is just passive cooling in the back of your panel, and that's effective enough. So there's going to be no fans to break. You aren't going to hear a whizzing when the unit turns on or anything like that. Incredibly quiet and incredibly reliable, because we're removing that one moving part out of there. So we don't need to worry about that for the future. And then your connectors there and viewing angle. So virtually what that means, the viewing angle there, 80 degrees from all directions, is no matter where this is in your cockpit, whether or not you have a 1 or a 2 display unit, you're going to be able to see it very effectively from anywhere.
Yeah, that's an important feature. I would, I routinely advise people when they're selecting avionics to make sure whatever avionics you're looking at, you try to, test it a little bit of what's your co-pilot going to see, what's your passenger going to see, or vice versa. What are you going to see if you're putting something in front of one of them? And that's pretty important unless you're absolutely committed to putting a system in your aircraft that's going to have 2 primary displays, which is, obviously a luxury. Otherwise, it really does help to be in a situation where your co-pilot is able to see everything that you are.
Absolutely.
So let's talk a little bit about required equipment. This is an important thing as a kind of step 1 in planning for what you need to do. First of all, the system itself consists of the display, which is what we've been talking about so far, and then a separate ADHARS unit, a magnetometer, and an OAT probe. Those are all the parts that come included that are separate components that need to go in there. That said, there's some things that you also have to have and some other things that it can work with, moving beyond that to external integration. So the top 2, you need to have an audio panel because it has audio learning that goes out through there, and you need to have the ability of obviously hearing that. We all pretty much have those, so that's not really much of a hurdle. And then a GPS navigator. The unit is a primary flight display, and in order to integrate everything and have navigation, you need to have a navigator to go with it. Obviously, an example of that is shown right in front of here. Now, outside of that, we'll talk about it in more detail, but you've got comm and nav integration, engine monitor, autopilots, things like that. Some of that's here today and some of that's coming soon. But one of the important things that we'll get back to here is that it can integrate with all sorts of things, which is a pretty significant differentiator, not just GPS only. So that's really, really important. And that leads us into, does it work with what you have? So the important thing here is not everyone is in a position where you're looking at a complete new panel as what you're doing, like soup to nuts. I'm going to put in a new autopilot, new navigator, new audio panel, new engine, like everything across the board, brand new. That's one of the advantages of a federated type system like this, which means a segmented approach to it, is that you have the ability of being compatible with a variety of things, being an open architecture to other things that are in your panel. And so it has a lot of compatibility, and that's key, that we'll certainly talk about. VOR, radios, ILS, radio navigation, GPS navigation, external integration with a variety of autopilots, a variety of engine monitors and things like that as well is important. And then understanding that does mean you're both analog and digital, and also that we'll talk about this more, but there's different protocols that different systems use, and the AeroVue Touch is designed to work with a variety of different ones. So in some cases, you may get your signal from 232, you may get it from our 422. We're going to talk about some things that get kind of into the weeds a little bit, but that'll explain that to you. Now, anytime that you are putting in a primary flight display in an aircraft, the FAA has gone and specified what are the backup requirements for all the different systems that are out there. And this is very, a good flow chart that you can kind of go down here and answer. You know, when can you remove your vacuum system? What independent things do you need? When do you need a backup battery, etc. The bottom line is attitude indicator, altimeter, airspeed indicator. Those things have to be in existence as backups. And then this chart, which is right in the installation manual, helps you go down and understand when you need backup batteries, when, you know, what other things you need to do. And the FAA has been evolving on this, these rules a fair amount when it comes to what really is required. But there's a very key point, the kind of distinguishing factor as you look into your installation to consider, and that is the FAA has talked about really just attitude indicators in some of their guidance. They've basically said, hey, if you have a standalone vacuum powered attitude indicator, then you can replace it with an electronic one. And, you know, again, there's specific guidance, specific recommendations about it. But look carefully and look very detailed into it, because much of their guidance is specific to standalone attitude indicators and attitude sources. Once you start attaching them to autopilots, and certainly once you start getting into primary flight displays, they have different rules about maintaining backup equipment. So that's a really important distinction. I'd encourage you to talk with your installer and to look at the regulations themselves and the guidance that's come out of the FAA, because it is a different thing when you are putting in an entire primary flight display than if you are just putting in an electronic attitude indicator, and what you're required to keep as a backup when you do that. So panel planning, it all starts with panel planning, of course. You got to look at what you have and what what changes you want, how you want to make it all work. And you know, the key here is planning for the future, understanding like what is likely to change in this revision if you're not doing a complete panel, you know, everything to your final state. Where are you likely to go next? And sometimes you can segment your panel. Sometimes you can only do certain parts of it that'll help you get to that final state. But it's really, really important to be able to do this. And then, as was found in some of the things that we'll talk about from people who have installed this, it's really important that you try to kind of use software to lay it out, but then also to involve someone who can actually do panel cutting for you. The shape seems simple enough, but even the display itself on the AeroVue Touch, the actual cutout you need to do is what's called an ATI type cutout. So if you look at the DME that is above the display and to the right, the upper right corner there, the one that's showing you with the older style red digits, that's considered that in that case that's a half ATI cutout. And a full ATI cutout might be your radar altimeter over on the right side of there. What that means is that those are standard sizes that have those angles at the corners. Those tend to be difficult to cut by hand or with saw or with a punch unless you really have a specific punch made for it. And so keep that in mind when you're doing any type of an installation, that rectangles are easy, and once you start getting into shapes like that, you really should be looking into a water jet or laser cutting or things along those lines. But again, it all starts with the panel planning there, and we move from there. And in the Cessna 182, that's exactly where everything started. So if you take a look at these notches that were made, the cutouts that were done, a whole new panel was designed from scratch for the 182, and it was all water jet cut in order to make everything fit. It lets you play around with some different configurations. It's got a really nice layout on this. It's all been anodized in this case, and love the way that all the circuit breakers were grouped. Everything was really redesigned. It's one of the best looking 182 panels I've certainly seen. But the key is, what's your current panel and what's your mission? How much sound time do you want, and what are you looking at? Like, is this the one and done that is going to be for the your ownership of the aircraft or your foreseeable future, or is this going to be your first move and you're moving some legacy equipment off to the right or something like that, and then you're going to move from there. Now, the other thing to keep in mind here, if you look at the backup instrumentation, I can back up for that. You notice it's right there below the AeroVue Touch. Those are requirements as well. So when you start thinking about what you'd like to do with your panel, you can't take your backup instruments, for example, and stick them over on the right-hand side. There are specific regulations of being within your field of view that have to be adhered to, and that's what resulted in the cutouts that you actually see here being used on the 182. So when you go through a process of doing an installation, any major installation on an aircraft, you have these steps, and we'll take you through some of that. Certainly, you've got the planning we talked about. You've got removal and preparation, power and sensors, panel design, unit installation, configuration, and then testing. And each of these involves a lot of decisions. You don't just it'd be great if you could kind of just drop it off and not have to think about anything. But the reality is, there's a lot of legacy stuff behind all of our panels, unless you're maybe building a brand new kit plane. And a lot of decisions need to be made about how deep you're going to get into that. So when you remove everything, what are you going to leave behind, and in terms of wiring, in terms of power? And we've certainly got some thoughts in that regard. And then you get to getting the power ready, getting the sensors ready, which includes your antennas. And then only then are you really ready for your final manufacture and installation of everything. So let's talk about in this particular unit. It all starts with the display itself we talked about, and you can see here, this is like the actual unit that kind of goes in. There's kind of a uniquely notched hole that has to get cut, and then the primary unit was called the KSD100. That's your display that actually goes in there, and that should give you a good sense of that. The next, and where it gets a lot more sensitive, is when we start talking about the sensors themselves. So two key sensors that are part of the AeroVue Touch system. The first is the KG71 ADHARS. That gives you all your air data and solid state attitude reference. This unit has to be installed in one of a cardinal axis, meaning like facing either exactly forward or exactly sideways, and you can actually tell the unit during configuration, tell the system during configuration which way it's been installed, which helps do all of that. Where it gets more challenging is when you start talking about the magnetometer. Magnetometers on any aircraft are extraordinarily sensitive to positioning. It's very, very important that since they are in the business, of course, of detecting very minute magnetic pulls to magnetic indications from the Earth, they are extremely sensitive to any type of interference or other electromagnetic signal that could come from a motor or a strobe light or anything that could be doing that. Even a simple incandescent bulb being anywhere nearby can throw off a magnetometer. And so in many aircraft, you actually go back to the manufacturer of where did they find the best location when it was an option. In the 182, it tends to be out in the wing, but there are in the Bonanza, it's in the tail cone. There are places that if it had a slaved HSI at any time during the life of the aircraft, then it had a magnetometer, and you can go to that same location and decide that that's where you're going to be able to put it. But otherwise, you really want to figure out how you're going to find something that's going to be as isolated as possible. Also, most of the magnetometers that existed from the past 20 years were round, and the magnetometers that are out today aren't the same shape. So you have to start with where in the aircraft you're actually going to find that quiet spot electrically, and then how you're going to mount it, because it also, again, has to be within a certain angle to be level with the aircraft. What's interesting during installation of the system is the aircraft itself has to be leveled as part of this. So all aircraft have level points on them. It's got a couple, so usually there's screws that you can pull out and put a level across it, and that's your starting point, because everything after that, where the ADHARS goes and exactly what angle it's measured at compared to the level point of the aircraft, like a magnetometer, etc., all has to be mapped and then translated during configuration of software, where you're telling it, I'm off by 2 degrees this way, so that you have an accurate system when you're all done. A small note to that, by the way, a lot of people are used to the old analog equipment where when a traditional vacuum powered attitude indicator has a little airplane and a knob, and the level line can be adjusted by the pilot based on your height, based on the parallax of the view that you're seeing. And so some people are thrown by the fact that when they first fly with an electronic primary flight display, it's constantly showing them pitch down in level flight, let's say. That's normal. That is because that is the true attitude of the aircraft compared to the level line of the aircraft. And that's how all of these systems are certified. So you've got the aircraft's level flight, a level point that the manufacturer designed it with, but the reality is, especially things like Navions and Grummons, they tend to fly a little bit nose down in practice. That's how they fly through the air. And what that means is that people tend to adjust for it with the old analog systems, and they're always looking at a level line. When they go and switch it over to an electronic display, poof, now it looks like they think they've got an issue with pitching down, but they don't. This is just the way that they all work. So just a note for everybody. Now, the next two parts of the system, the OAT probe and the knob panel. The OAT probe is fairly straightforward and helps you, of course, with density, altitude, outside temperature, etc. And what's nice about the switch panel, the dial panel, is that during this whole layout process and design process for your aircraft, you can decide if you want this to be in a vertical orientation or you want it to be in a horizontal orientation. And you really should kind of I've encouraged people to mock it up, and even mock it up on some paper in front of you, and see what it's like to reach out, and how it fits compared to a touch screen, especially that you're going to be interfacing with, where those knobs make sense for you. And jumping back a few slides just to show you where it was in this design, on the 182, it went on the right-hand side, top to bottom. Makes a lot of sense there. Allows you to use those controls through the touch screen with the handholds that are really easy to use to balance your hand and use the touch screen, and then reach over to the right and be able to use those knobs. So let's get back down there. Okay, so once those are in, next thing, of course, you've got to go through a whole post-installation process that's involved, and that whole process there involves your displays, your sensors, your interfaces, radios, navigation, etc., and your databases. There's a lot that goes into understanding the difference, making sure that everything is properly tested and that it's all working properly. And there's a lot to the design process as well as you go and do that. So let's actually, we back up a minute and we talk about this and we think about the design. We started earlier on by talking about legacy equipment and what you're going to actually work with, as well as your current equipment that's part of the install. Let's say if you're going to be putting in one of the AeroNav systems as well. Each time, all these data signals, you're sending to GPS data. You're sending data that has to do with the aircraft's attitude. You're sending, let's say, ADSB, traffic data, weather data, autopilot deviation information. There's a lot of different data that's flowing around the aircraft. And one of the things that's important during the design stage of figuring out how you're going to do it is that much of the data can go in more than one protocol. What that means is you have, let's say, there's only a few of them. You have 3 different key ways that data can go behind a panel. You have like RS-232. We've heard that with PCs and things like that. That's one way that the data flows inside of an aircraft. You've got 422, which is another protocol. You've got AirInc 429. Now, we're not trying to, make everyone avionics shop experts when it comes to doing this, but here's the key. The key is you have to lay out and look at each of the different boxes and say, this one's going to be sending its data, and it has this protocol available to send data. And then it's going to receive this other data. Well, what protocol does it have available for that? And so in many cases, you have more than one option, and only by drawing it all out, by laying it all out, can you choose the right matches for everything you have there so that it all makes sense and so that you don't run out of ports, let's say. It's just like having a variety of USB ports on your PC. You've got to decide what you're going to use them for and when you can use a splitter. And so your avionics shop's going to help you with all that. I'm not trying to say that you have to solve it now, but this is all part of the design process, and it's all part of what went into making these decisions on how it went into the 182. Some tips and tricks when this goes in. First of all, here's your real install on the right, and it's one of the installs. This one is in a Beechcraft, and one of the key things to consider here is really this growth for the future of what you want to do. You're breaking into your panel, and the labor of doing that is extremely high, and you really want to try to make it so any future time that you have to go back here is going to be minimized as much as possible. The way to do that is that when you get back there, to have your installer kind of forward wire things as much as possible and then label them. So, for example, on the AeroVue Touch, there's the installation manual specifies a whole slew of features that are coming and will have data sources or new features down the road that have to do with engine monitor displays, that have to do with autopilot integration features, all sorts of things that are coming that you don't want to get back into the wiring if you don't have to in the future. So what you can do is have your installer actually take all the different identified pins and put them all into a connector to be used for the future and document it. So you literally have a connector sitting behind your panel that has, could be 25 different pins pre-wired for the future, for something you know is coming, so that when it's time to actually go use that in the future, they can wire something up on the bench that's a mating connector for it when they're going to do the install and just plug it in when they get into the aircraft. It will save you an enormous amount of money and make it very, very easy for you to upgrade in the future. The same thing is true when you're dealing with the legacy avionics that you see surrounding the AeroVue Touch in this display. Whether it's the DME or whether it's annunciators or anything like that, these are all things you can pre-wire for. And I would encourage anyone who's dealing with an installation like this to also make sure that someone's making a kind of like a common ground panel that all the avionics are grounding to. We all think about power as what's, obviously sending energy to all the things on our devices. But where things tend to fall down behind the panel for general aviation aircraft is really often in grounds. And so when a lot of new things go in there, it's a lot of people, you're wiring, power goes here, comes from a circuit breaker. We put in new wire. But where are all the grounds going? Because all that energy has to come back, and it needs to all go to a common point to reduce noise and anything else that could cause trouble. And be very accessible so that future things can also tie into that exact same ground and know that it's all clean. So that's a really important point there as well. Some lessons learned. We've got a couple installations. We met earlier today with Joe Coraggio, who's put in the AeroVue Touch in his Lancer. We talked with the team that did the work on the 182. We've looked at other things as well. Some of the keys that everyone talked about. The first one we touched on, panel manufacturing. And, fortunately, the prices have come down that usually you can send something out to get done, but that is key due to some of the many different shapes involved. Magnetometer placement, we talked about, that is one of the things that can hang people up. So as a lessons learned is like hit that early, figure out early where that is on your aircraft, where it's going to work, how you're going to figure it out. And then interface planning, like that is, I'd hit interface planning before I'd even get to layout of the panel. I'd really want to kind of understand, like, what do you really want to keep? What's coming? Is it a legacy autopilot? Do you have what radio navigation is going to come in? All those are all key things to mapping it out. And at the end of the day, more important than even a schematic that would show you, wire for wire, what really matters is this kind of logic flow of where is your data coming from and where is it going to? And you draw that out in boxes. And that helps you understand things. And it also is the thing you're going to go to the most in the future when you need to switch things off. I did something with this that had to do with ADS-B in my own aircraft. I had satellite XM weather and also had ADS-B weather. And what I did was I had to think ahead, like, do I know if I'm going to want to keep satellite weather forever? And the answer was, I don't know if I'm going to keep it forever. So I needed to decide which is going to go where and how to wire everything in a way that when it came time to decide I'm going to, let's say, cancel an XM subscription, the only thing I needed to change was a software setting. Because I'd already put the wiring in place that had ADS-B going to all the devices, and I only needed to change a setting to stop using the port that was bringing in XM. So it's just kind of an example of interface planning and planning for your future. And then the last thing here is really kind of simple and crude, and that is I've seen more problems with people using 30, 40-year-old circuit breakers than I care to say. More times have we had intermittent avionics issues that come back to an old circuit breaker than you can imagine. Some of these have even been fatigue failures where the tab literally breaks off from vibration of 40 years. So these things are not that expensive. If you are going to be doing a panel, switch them over, put in new circuit breakers. And that's just a tip and a lessons learned along the way. So, Steve, would you have anything? Would you like to add and chime in on some of that?
No, I think that you definitely covered it very in depth, and I appreciate that, Jeff, going through. But yeah, in general, the big things that from both the folks that we talked to, Joe Coraggio especially, I'm going to re-emphasize that machining of the panel. It may not seem like it's a huge deal, but Joe said it saved him potentially weeks of trying to get cutouts right and everything, and it just makes for a much cleaner look and feel. It can get anodized typically at the same place if you want to go that route, but it makes life a whole lot easier. So I just kind of want to reinforce that one point. And then, yeah, apart from that, Jeff, I think you did a great job covering everything. And then follow up with us. If you have questions, maybe on a specific airplane that's you're flying, that you want some advice on, anything along those lines, my contact information is right there. So that is personal work email. It comes directly to me. I will respond to you as soon as I can with any updates and to help you through any questions that you might have. So please feel free to give me any questions, comments, directly to there.
Excellent, and thanks, Steve, so much for tonight, and to everyone who took time out of their evening to join us. If you have any questions, certainly follow up. I mean, the goal of tonight is to let you know that the AeroVue Touch it's here, it's real, it's getting installed into people's aircraft. We're starting to see the benefits of that and get the stories. And wanted to give you a sense of like, what are the different components? How does this fit? What do you need to think about for putting it in there? And if you have a chance, find a way to go see it, because I'll tell you, it's a really impressive system to take a look at and see how it fits into your aircraft. So for helping BendixKing present this to you this evening, and for SocialFlight, I'm Jeff Simon. Thank you so much, and we will follow up with you next time at our next webinar. Blue skies.